This is an optical mouse. The way it works is the following. It's got underneath it an LED. It's a red light, basically. It's underneath the mouse. When I move the mouse around on my computer, the LED touches my surface, so like my desk. And what happens is it reflects off my desk to a sensor which is also in the mouse. It's normally at the front of the mouse. The reason why it does that is it turns it into like a binary value. This value is given to the computer. It then basically detects where my mouse is and what movement I've done. So let's imagine my mouse was here. I've moved it to the right. This is my starting point. I'm going to drag it to the right. It's going to end up here. It's going to use calculations to do that so that my cursor, my mouse cursor, actually ends up here as well. It works because the LED is shining down on my desk. It's going to my sensor. I then drag my mouse to the right, and the LED is touching down on my new position to the sensor. It calculates the jump, and my cursor ends up over here. So imagine my mouse was over here, my mouse cursor. So remember, a mouse cursor is like an arrow. In this situation, it's this red dot. It's going to jump from here to here. So it determines the direction and the speed of my movement. So there's a calculation to work out not only where I'm going to, but how fast I've done it. And it shows in real time my mouse cursor moving as well. If I'm doing it slowly, like that, it would also do the same. So to repeat again, it works by an LED underneath the mouse. It's a red LED which reflects back up off the surface to a sensor. The reason why it does this is so that it has a value. That value is then sent to a computer. The computer then determines which direction I put my mouse in and the speed, and it updates my cursor or my action. This is a computer keyboard. I push down a key on my keyboard. When I do that, what happens is the following down below. I push down the key. Underneath the key is a circuit. This circuit is incomplete. You can see in a second that there's a gap here. The moment I press down the key, the circuit is complete. When that circuit is complete, it's going to send data to my computer. The computer is then going to know which key I've pressed on the keyboard and display it on the screen or respond. So I'll say that again. You push down the key on the keyboard. Underneath all the keys are incomplete circuits. So there'll be another key for A. There'll be another little switch here, like we've got here. Oops. That's the switch. And we've got a circuit underneath, which is open. The moment we push down on the A key, the circuit becomes complete. It sends a signal to the computer. The computer then is able to calculate which key, and we use that word calculate, which key has been pressed. Simple as that. What do you need to know for your GCSE? Well, you need to know basically this text here. This diagram is just to help you. It does have some additional information, like that, and the insulating layer, etc. But this is basically what you need to know. What we're going to be looking at now is basically computer mics. Computer mics work very similar to normal mics, where basically you have sound waves. Like my voice is a sound wave. It goes into the mic. Normally, old school, what would happen is, an old school mics, not computer mics, it will just output so you can hear my voice projected on speakers using normal sound waves. But in computer terms, you've got your sound wave. It goes into my mic, that's my mic, and it actually gets turned into digital. So that the computer can process it. The microphone has a diaphragm inside of it. That diaphragm responds to the vibrations in the sound waves. So if I'm shouting, if I'm being quiet, it can adapt. These vibrations, old school, would be turned into signals which you can hear on the speaker. But for computers, it gets turned into electronic signals, which are then sent to a microprocessor, shock horror. And it's basically turned from analog sound waves to digital. There's a coil attached to the back of the diaphragm, which is able to basically do the conversion from analog to digital. So let me go through the steps again. Sound wave goes into microphone. Diaphragm, with a coil, picks up the different vibrations, and it's then converted from analog to digital, which is then sent to the microprocessor of my computer. That allows me then later on to edit sounds. I could also copy sounds or duplicate. I can delete sounds. So if I edit, I can quieten my voice on the mic. You can't do that on old school mics because it just outputs straight away what you're doing. But I can use an editor to quieten myself or make myself louder or get rid of background noise if I can really be bothered. So these are the benefits of using digital sound.